Alright, so the last concept of vectors will be called the position vector. So what is a position vector? Position vector always starts from the origin. Okay, so imagine I have a coordinate system, right? So point A will be 1, 3. Right, so if I label 1, 3 in my Cartesian plane, will be right here. Right, so this is point A, where point A is 1, 3, and point B will be negative 3, 1. Right here. Alright, so how do I change these two coordinates to a position vector? Basically, a vector is something like an arrow. Yeah, so you just need to draw an arrow starting from the origin. So from the origin, you draw an arrow, and this arrow is called a position vector A, or they like to call it OA, because for a vector, I always start from a particular point and end at a particular point. So I start from origin and end at the point A. Okay, so how do I represent a position vector? Very simple. You just copy everything the same, just that the 1 and 3 must be denoted in such a particular orientation. Alright, so remember, for the what does the 1 and 3 represent? This is basically the same as your column vector. Your 1 represents the horizontal, and your 3 represents the vertical. Okay, so yeah, so this is for OA. What about OB? OB, I need to draw an arrow again from the origin to the point B. Okay, and I label this as OB. And OB will be represented in negative 3, 1. So where negative 3 is the horizontal and 1 is the vertical. Alright, so negative 3, why is it negative? Because remember, from the concept of column vector, when I'm talking about positive direction, positive direction means I'm going towards the right hand side, and or I'm going upwards. Okay, because normally when we are going upwards, we are going towards the right. It's called positive, and negative will be leftwards and downwards. Okay, so if you look at the green arrow OB, right, you notice that my horizontal, I'm going from 0 to negative 3. So it's a negative direction, but my vertical direction is still positive because I'm going upwards in this particular direction right here. Alright, so this is your position vector. Okay, so yeah, so OA is 1, 3, OB is negative 3, 1. Alright, so next will be the calculation of AB using our position vector OA and OB. Alright, so how do we calculate? So remember, for AB, we want to start from A, point A, right, and go to point B. So let's draw an arrow. Okay, so I start from A, I go to B. Okay, so this blue line is what we call AB. But the question is, how do we calculate using just the information from OA and OB? Okay, so same thing, we need to use the idea of the addition and subtraction of vectors. Okay, so if you still remember your addition and subtraction of vectors, we always use OB, the final, minus away the initial OA. Okay, so if I manipulate a little bit to see whether I can get AB. Okay, so OB remains. Okay, then after that, because for vectors, I try to get rid of the negative sign. Alright, so plus negative OA. Okay, so negative OA itself must flip, right? Is equal to AO. Okay, so my final form will be OB plus AO. Okay, but if you notice one thing is that my alphabet right here, they are not the same. So I can't just add them up in such a manner. But I can shift my AO to the first, right? To the first position, which is right here. AO, then I shift my OB to the second position, which is OB right here. So now we have the same alphabet, O. And I can add them up to get my AB. Okay, so this is how you add up two position vectors. Okay, so when you're adding up two position vectors, you always use the final alphabet minus away the initial alphabet, so that you can get your vector that you are interested in.